So good morning, welcome to Sakala Vidya YouTube channel. So welcome you all, Mr. Lokesh Nayak, IAS, welcome, Shivani, Shravani, Lakshmi, Mokshit. Okay, yesterday we had a discussion up to these 4 problems. Today we discuss do these problems. Page number 66 before this 3.3 exercise. Okay, page number 66. This is do this activity. Do this. Textual questions today we shall discuss. Right, this is actually for 10th class. So now the question in this one, first question, find the zeros of a quadratic polynomials given below. Find sum and product of the zeros and verify relationship to the coefficients of terms in the polynomial. This is the question. That means we need to verify the relationship between sum and product of the zeros and their coefficients of the terms of the polynomial. So that we need to discuss now today. First question we have. The first question, P of x equals to x square minus x minus 6. So first we need to find out sum and product of the zeros, and then after that we need to verify the relationship to the coefficients of terms in the polynomial. So what is the plan? Plan of action is like this. So plan to solve this problem, how to solve the problem is we should need a plan. First step we find zeros. Second, let the zeros be alpha, beta. Then find alpha plus beta and check whether it is minus b by a or not. Find alpha, beta, check it is c by a or not. This is our plan of action. Okay, now let us find out zeros now. Already you know how to find out the zeros. The procedure now let us start. Solution. Here given P of x equals to x square minus x minus 6. For zeros for zeros, the p of x is equated to 0. So we get p of x is equal to x square minus x minus 6 equated to 0. So now it's a quadratic equation. Now we need to solve it now. So that means here we get minus 6 into x square coefficient is 1. So minus 6 should be product of the two numbers and x coefficient is minus 1 equal to sum of the two numbers. That means we need to find out two numbers whose product is minus 6 and whose sum is minus 1. First write down 3 2 ja. Here also 3 2 write down, but 3 plus 2 is 5, but we need minus 1. Put minus sign here. Minus 3 plus 2 is minus 1. Minus 3 into 2 is minus 6. So that means we need to split the middle term minus x as minus 3x plus 2x. So minus 3x plus 2x is minus x. So we need to write the middle term as, we can write like this, x square minus 3x plus 2x and minus 6 equals to 0. From the first two terms, let us take x common. We have x minus 3. Take 2 common from the next two terms. So we get 2 times x minus 3 equal to 0. So take x minus 3 common out. We have x minus 3 times x plus 2 is equal to 0. So as the product of two numbers is equal to 0, either first term or second term or both may be 0. So we get here you check, x minus 3 equals to 0 or x plus 2 equals to 0. So we need to solve these two linear equations so as to get the zeros. So x equals to 3 and x equals to minus 2. So therefore minus 2 and 3 are the zeros of p of x equals to x square minus x minus 6. Here one more thing write down here. See here, x square coefficient. X square coefficient is equal to 1. Coefficient of x is minus 1. Constant term equal to minus 6. Okay, just keep aside this one now. Now let us find to here, now we need to find out the sum of the zeros. Sum of the zeros, you can say alpha beta also, no problem, directly find out. 3 plus of minus 2, you will be getting 3 minus 2 whose value is 1. But this one we need to write in terms of the coefficient of x and x square coefficient. This can be written minus of minus 1 write down upon 1 write down. See, this minus 1 refers to coefficient of x, 1 refers to coefficient of x square. So this can be written as minus coefficient of x upon coefficient of x square. Let me write clearly this one. This we can write minus of minus 1 upon 1 write down. It makes no difference. This minus 1 is the coefficient of x, but minus is there. Minus coefficient of x upon 1 is the x square coefficient or coefficient of x square. That relation has been established. So now product of the zeros. Product of the zeros. See, the product of the zeros equals to, so what are the zeros now? See, 3 and minus 2. So we need to find out 3 times minus 2. That will be minus 6. So now you check here, minus 6 is the constant term. We need to relate constant term to the coefficient of x square. So that's why this minus 6 can be written as, for our convenience, minus 6 upon 1 write down. So this is nothing but minus 6 is constant term, not minus constant, only simply constant term, upon 1 is being coefficient of x square. Coefficient of x square. That's why we conclude that it can be generalized that sum of the zeros is equal to minus coefficient of x square by coefficient of x square. Next, actually, product of the zeros is equal to constant term by coefficient of x square. The problem has been completed. So let us move to the next question now. Next question. Second question. Are you ready? Second question is P of x equals to x square minus 4x plus 3 okay. So now here we need to find out, verify the relationship to the coefficient of the terms in the polynomial and their zeros. Okay, so what's the plan here? Once again, plan. What is the plan need to be implemented to solve this problem? First, find zeros. Find zeros. Second, find sum. Next, third step, product. And fourth one is verification. Verification. So these 4 steps need to be followed to solve this problem. So now let us solve it now. Solution. For zeros, the P of x is equated to 0. First, given write down. Here given is P of x equals to x square minus 4x plus 3. So for zeros, P of x is equated to 0. So that what you get now? Yes, you are correct. You may get x square minus 4x will be equal to 0. Now we need to solve this equation now. How to solve? See, 3 into x square coefficient 3, constant, x coefficient is minus 4. So we need to write like this, product of 2 numbers and sum of 2 numbers. So that means we need to search for 2 numbers whose product is 3, whose sum is minus 4. So that means we can write like this, 3 times 1, but we need negative 4. Negative 4 means write down minus 3 minus 1. But here also we need to write like this, minus 3 minus 1. Check it. Minus into minus plus. That's why the middle term minus 4x can be written as minus 3x and minus x is equal to minus 4x. So now let us solve it now. X square, the middle term has been actually split up as minus 3x and minus x plus 3 equals to 0. What shall we do now? From the first 2 terms, let us take x common out. We have x minus 3. From the next 2 terms, minus 1 common. If you take minus 1 common, same, we'll get common. X minus 3 is equal to 0. The next step, you may expect that x minus 3 has been taken common out. We have x minus 1 equals to 0. So now here 2 cases will arise. X minus 3 equals to 0 and x minus 1 equals to 0. Am I correct now? Now what shall we do? What shall we do? So we need to find out, we need to solve these two equations. So transpose minus 3 that side, you get x equals to 3. Now x equals to 1. So therefore 1 and 3 are the zeros of P of x equals to x square minus 4x plus 3. In the plan, the first part has been completed. Mokshit Reddy, absolutely correct. Okay, next go for now the verification part you need to go for. Now sum of the zeros, let us find out. Sum of the zeros means here 1 plus 3 write down. 1 plus 3 equals to 4. But we need to relate this coefficient of x to coefficient of x square. This 4 can be written for our convenience. Minus of minus 4 write down. But in the denominator you can write 1. Minus 4 is the coefficient of x. 1 is the coefficient of x square. So this we can write minus coefficient of x upon 1 being coefficient of x square. So it has been verified the relation between sum of the zeros and coefficient of x square. Okay, next now product of the zeros. So let us find out product of the zeros. You can try yourself also. So product of the zeros means what are the zeros? Just we have evaluated 1, 3. So now 1 times 3 equal to 3. But we need to establish the 3 is the constant term to the coefficient of x square. So that this we can write 3 upon 1. So this is equal to constant term upon coefficient of x square. Yes, the problem has been completed. So problem has been completed. Right. Next we shall move to the third problem. P of x equals to x square minus 4. It's very interesting problem. Do you know what you call this equation? Anybody? Mokshit Reddy? What is the name of this quadratic equation? Sorry, polynomial. Can you name it? Okay. In the meantime, I will discuss. Same plan need to be applied here. What is the plan now? What is the plan of action to be implemented? First, find its zeros. Second, sum of zeros. Third, product of the zeros. Fourth one is verification. So these steps are to be followed. This is the plan to solve the problem. No, it's not a quadratic. It's a quadratic polynomial. Other name is there. You try. Now the solution. Given P of x equals to x square minus 4. In the first step, we need to find out zeros. Zeros we need to find out. So for zeros, P of x is equated to 0. So as for the question, P of x is x square minus 4 equal to 0. So if you observe the left hand side is in the form of A formula, wonderful formula we have. What is that? A square minus b square, which can be written a plus b times of a minus b. Am I correct? So that the left hand side can be factorized as, this can be written now, x square minus 2 square equals to 0. So just applying this formula, this can be written x minus 2 into x plus 2 equals to 0. First we need to find out zeros. So we get x minus 2 equals to 0 and x plus 2 equals to 0. Transpose minus to this side, we get x is equal to 2. Transpose to this side, x is equal to minus 2. Therefore, minus 2 and 2 are the zeros of p of x equals to x square minus 4. Yes. So now Anil ready. Sum of the zeros. Sum of the zeros. So add these two. Very interesting. This is 2 plus of minus 2 is 2 minus 2 is 0. That means sum of the zeros of x square minus 4 is 0. Because coefficient of x is absent, always sum of the zeros become 0. You remember, this is very important question, may appear in examination also. But this 0 we can write like this now. So minus of 0 upon 1 write down. This is minus coefficient of x upon coefficient of x square. Coefficient of x square. This is a relation. Sum of the zeros. Next, product of the zeros. So the product of the zeros is equal to 2 into minus 2, that will be minus 4. Just you check it now, minus 4. Minus 4 is the constant term. X square coefficient is 1. So for our convenience, this can be written minus 4 upon 1. So this equals to constant term upon coefficient of x square. Coefficient of x square. So now okay. Next one is fourth question. P of x equals to x square plus 2x plus 1. X square plus 2x plus 1. Okay, same plan need to be applied for this one also. Solution given P of x equals to x square plus 2x plus 1. For zeros, P of x equals to 0. That implies x square plus 2x plus 1 equals to 0. See, now this will be in the form of a square plus 2ab plus b square. You can write a plus b whole square. So this can be written as x plus 1 whole square. Now x plus 1 whole square equals to 0. This we can write x plus 1 times x plus 1 equal to 0. Now x plus 1 equals to 0, x plus 1 equals to 0, x equals to minus 1, x equals to minus 1. Yes, very interesting. The zeros are coincident. Zeros are coincident to minus 1 comma minus 1. That means it has only one zero, but they are coincident. They are coincident. So now sum of the zeros. Sum of the zeros is equal to minus 1 plus minus 1. So that is minus 2. This minus 2 can be written as minus 2 upon 1. You check. So 2 is the coefficient of x, 1 is the coefficient of x square. So this we can write now minus coefficient of x upon coefficient of x square. So this problem is very important for 4 marks. Please try to concentrate, all of you. Now product of the zeros. Product of the zeros. So that is equal to minus 1 times minus 1. So you get 1. 1 is the constant term. This can be written 1 upon 1. So constant term So 1 is the coefficient of x square. Coefficient of x square. The 4 problems have been completed now. Okay. One minute. Till then you check the solution. One minute. Let me add the pages. Later we shall have a discussion. Okay. Right. So page number 67. Example 3. Example 3. Find the zeros. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients So try yourself. So otherwise, just explain me the plan. What is the plan need to be applied here? Plan has 4 steps. Those 4 steps you chart in the chart box. What are the 4 steps need to be implemented? So in order to solve this problem. So what is the plan? See, the plan is like this. So plan to be implemented. First find zeros. Second is sum of the zeros. Third is product of the zeros. Fourth one is verification. That's all. So this is the given polynomial x square plus 7x plus 10. We need to verify relationship between the zeros and coefficients. Okay. Solution. Given p of x equals to x square plus 7x plus 10. Yes, first step. Correct, Mukshit Reddy. For zeros, p of x is equated to 0. Yes, very good, Sivani. So that implies x square plus 7x plus 10 equals to 0. Now we need to write like this. 10 equals to product of two numbers, coefficient, x coefficient is 7, sum of the two numbers. See, now we need to search for the two numbers whose product is 10, whose sum is 7. So 5 2 ja write down, 5 plus 2 write down. Okay, that's all. 5, this is plus, this will be plus. 5 plus 2 7, 5 into 2 10. So that's why the middle term 7x can be written as 5x plus 2x. This we need to apply strategy. So now we can write this x square plus the 7x can be written as 5x plus 2x plus 10 equals to 0. Now from first two terms let us take x common. We have x plus 5. Next two terms take 2 common. We have x plus 5. Now what shall we do? Yes, we need to take even x plus 5 common. So x plus 5 times x plus 2 equals to 0. So next step follows. X plus 5 equals to 0 and x plus 2 equals to 0. So now transpose 5 this side, you get x is equal to minus 5, x is equal to minus 2. Therefore minus 5 and minus 2 are the zeros of p of x equals to x square plus 7x plus 10. This the first part has been completed. Yes, Sivani, next we go for sum. Now sum of the zeros. Sum of the zeros. Sum of the zeros means these to be added. Minus 5 plus of minus 2. That will be minus 7. But here coefficient of x is 7. We need to write as a 7. So this we can write minus of 7 bracket upon 1 radon. 1 is the coefficient of x square. So this can be written minus coefficient of x upon coefficient of x square. So we have established the relation between sum of the zeros and their coefficients. And one more thing is left, a product of the zeros. So product of the zeros is equal to product of the zeros. The product of the zeros is equal to, what do you get now? Minus 5 multiplied with minus 2. You get minus into minus plus 10. But you check what is 10 here. 10 is the constant term. Coefficient of x square is 1. So this can be written for our convenience 10 upon 1. So that is constant term upon 1 is being coefficient of x square. So it has been verified. It has been verified. Example 4. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So this is somewhat a different problem. Shivani, plan, let us implement. Anybody give the plan? So what is the plan of action? So once again let me write the plan for this problem also. Plan. What is the plan? First let us find out zeros of this polynomial. Zeros. Find zeros. So second is sum. Third is product. And next is verify. That's all. These 4 steps need to be kept in our mind to solve this problem. Right. So this is the polynomial. Now the solution. Given p of x equals to x square minus 3. Right. For zeros, p of x is equated to 0. That implies x square minus 3 equal to 0. So this can be written as like this: x square minus root 3 whole square equal to 0. Because you just observe root 3 square equal to root 3 into root 3, we get 3. So that means 3 can be written as root 3 whole square. Again, in the left hand side is in the form of here a square minus b square form, which can be written as a plus b times a minus b. So this left hand side can be factorized like this: x plus root 3 times x minus root 3 equal to 0. So my dear students, you can generate questions like this also. Instead of x square minus 3, take x square minus 5, x square minus 7, x square minus 15, and like that you solve the questions. You generate the questions and solve it. Then you will get more practice. Even it will be useful for your formative assessment examination also. So next, x plus root 3 equals to 0. We get x minus root 3 equals to 0. So x equals to minus root 3. I need not explain, directly you may have the idea. So therefore we conclude that minus root 3 and root 3 are the zeros of p of x equals to x square minus 3. Yes. Now the verification part begins. So, now sum of the zeros. Don't write short form in the examination. Write sum of the zeros equal to minus root 3 is added with root 3. Minus root 3 is called additive inverse of root 3. Root 3 is called additive inverse of minus root 3. This cancel, we get 0. So this, for our convenience, you can write minus 0 also, no problem, by 1. This is minus coefficient of x upon 1 being the coefficient of x square. Coefficient of x square. Now product of zeros. Product, don't write product of zeros. It need to be mentioned very clearly in the examination, because in 10th class each and every step has vital role to get the more marks in the examination. This equals to minus root 3 times plus root 3. Root 3 into root 3 but minus 3. You go to the problem. See, this minus 3 is the constant term. Coefficient of x square is 1. So this we can write minus 3 upon 1. So constant term. So by observing all these problems, actually you might have got an idea. Sum of the zeros of a quadratic polynomial is minus coefficient of x by coefficient of x square. Product of zeros is equal to constant term by coefficient of x square. This has been generalized. Even yesterday also we have given the proof also. So this need to be addressed while solving the any problems. Example 5. Find the quadratic polynomial whose sum and product of the zeros are -3 and 2 respectively. This is the question. This is somewhat different from the previous problems. See, find the quadratic polynomial or frame the quadratic polynomial whose sum is -√3. Product of the zeros is 2. Sum of the zeros is -√3. Product of the zeros is 2. So what is the plan to be implemented? That means here plan, what is the plan means? Already sum is given. Sum is given means alpha plus beta given -3. Product given alpha beta is equal to given. Then recall the formula. What is the quadratic polynomial? That is k times x square minus of alpha plus beta into x plus alpha beta. Just your work is -3 and 2. We need to substitute here, we get the answer. But here you need not find out alpha plus beta and alpha beta. Directly alpha plus beta, alpha beta given in the problem. Please remember, this problem is different problem. Okay. So let us implement this plan now. Solution. First write down like this. Let alpha and beta be the zeros of a polynomial. This is the first step. Next step is we have alpha plus beta equals to -3. This one. Alpha, product of the zeros, alpha beta is equal to 2. Recall this formula. So the quadratic polynomial is given by P of x equals to k times x square minus of alpha plus beta times x plus alpha beta, where k does not equal to 0. Substituting respective values. What are the values? -3 and 2. Alpha plus beta is equal to -3, alpha beta is 2. So that means here, since alpha plus beta is equal to -3, alpha beta is equal to 2. So these two values we need to substitute here. So therefore we get P of x equals to k times x square minus of -3 of x 2. This is k times x square minus into minus plus 3x plus 2. See, for different values of k, you get the different quadratic polynomials. So many infinite number of quadratic polynomials can be formed. So that means depending upon your k value. If you take k is equal to 1, 2, 3, 4, k is equal to -1, -2, -3, and like that, as many as values you can take it, no problem. Right. So Mokshit Reddy, you have written only one of the values. You have taken k is equal to 1. But it has many quadratic polynomials you can frame. Example 6. Example 6. Find the quadratic polynomial whose zeros are 2 and minus 1 by 3. 2 and minus 1 by 3. See, now your plan will be changed. First step, let us say this is alpha, this is beta. Here not alpha plus beta, alpha beta has not been given here in this case. Alpha is equal to 2. Okay, Puneet, welcome Puneet. Beta equals to minus 1 by 3. Second step, find alpha plus beta. Third step, find alpha beta. Then substitute these two values in P of x equals to k times x square minus of alpha plus beta into x plus alpha beta. That's all. So this is the plan. Okay, let us implement it, our plan now. Solution. Let alpha and beta be the zeros of the quadratic polynomial. The quadratic polynomial. Given. Zeros given, not a sum and product. Given alpha is equal to how much given? Alpha is equal to 2 and beta is equal to minus 1 by 3. Now first step, second step, alpha plus beta we need to find out. 2 plus of minus 1 by 3. This can be written plus into minus minus 2 minus 1 by 3. We need to simplify. Take 3 LCM. 3 2 is 6 minus 1, 5 by 3. So simplification you need to do very carefully. Next one is alpha beta. Alpha beta equals to 2 times minus 1 by 3. That is minus 2 by 3. So next, the quadratic polynomial. The quadratic polynomial is given by the quadratic polynomial is given by P of x equals to k times x square minus of alpha plus beta into x plus alpha beta, where k does not equal to 0. So here alpha plus beta is 5 by 3. Alpha plus beta is equal to 5 by 3. Alpha beta is equal to minus 2 by 3. So here and here we need to substitute. K times x square minus 5 by 3x minus 2 by 3. But here one thing we can do, So now put k is equal to 3 or 6 also, no problem, multiples of 3. Therefore the p of x equals to, we get like this, 3 multiplied by x square minus 5 by 3x minus 2 by 3. Open the brackets. 3x square minus 3 gets cancelled, minus 5x, 3 gets cancelled, minus 2. That means if you want to write as the integral coefficients, you can make like this. That's why in Moksha Reddy you keep this idea. So quadratic equation is only unique, but whereas the quadratic polynomial is not unique. So intermediate classes will be evening. Okay, thank you, bye, see you. So tomorrow we shall have one more interesting chapter we shall discuss. Thank you, bye bye.